Most powerful Tesla's massive machine, the Giga Press. Tesla is known not only for its self-driving car technology, but also for its fine and durable vehicle parts. An astonishing new video of one of Tesla's robots removing a sizable casting portion from one of its Giga Press machines was previously posted by the company. So what is this machine? Why is Elon Musk so keen on upgrading it? Let's find out. In this video, we'll take a look inside the Tesla factory where a massive machine, the Giga Press, works hard to shape Tesla vehicles. Let's see how it works and why Elon Musk prefers it over other methods. The largest casting machine in the world was purchased by Tesla in many units. Hydra is the company that creates these enormous, expensive machines. 2020 saw the start of operation for Tesla's first Giga Press, which was installed at the Fremont facility. The device, which at the time was the first of its kind, has a clamping force of between 55,000 and 61,000 kilogram newtons. By 2022, there will be nearly 6 Tesla factories spread out around the globe. The Fremont factory was the first EV manufacturing facility of these. While only solar panels are produced in Giga, New York, Giga, Nevada manufactures lithium-ion batteries. The fourth and first plant that Tesla has built outside of the US is the Giga Shanghai. This manufacturing plant has been producing electric automobiles in China for almost 1.5 years. The two facilities that need to be finished are Giga Texas and Giga Berlin. All of Tesla's plants are already successfully using the 6,000-ton Giga casting machines. Tesla's been making significant investments in alloy and casting technologies over the past few years to enable larger cast parts that have the potential to significantly streamline manufacturing. Let's look at the advantages a Giga Press offers to understand why Tesla is so eager to use this device in the production of cars. The production efficiency of huge and complicated vehicles is significantly increased by the Giga Press. Manufacturers may cast a single large component rather than multiple smaller ones thanks to the Giga Press. As a result, it essentially eliminates the necessary assembly activities. Thus, it makes significant time and labor savings that eventually lower production costs. The manufacturer can create a lightweight framework and add extra strength to the casting by casting it in a larger single piece. The danger of having alignment problems with parts during assembly is also eliminated by casting a single component. Thus, it makes quality control simpler and enables producers to produce castings of the highest quality. Additionally, it drastically reduces the size of the body shop and the manufacturing of robots. Therefore, there are savings in the use of land. One rear body piece that replaced 70 separate pieces of the Model Y has already been used in production by Tesla. The machine is used to cast the car's one-piece front end and one-piece rear end. Since then, Tesla has made significant investments in the technology behind massive casting. That was the company's first significant step into large cast parts. The anticipated Cybertruck, another Tesla vehicle, will have its rear portion cast using another sort of Giga Press with a clamping power of 8,000 tons. This method has drastically reduced the number of robots required to produce 1 unit of output at Tesla's body shops. Tesla's Giga Press is made up of 7 parts. Let's examine how each one functions. Ovens. The aluminum alloy is handled by 2 sets of ovens in the Giga Press. One has an operating temperature of 850 degrees C and serves as a melting oven powered by natural gas. Another oven, which runs at a temperature of 750 to 850 degrees C, is used to store liquid metal that has been cooked by electricity. Giga Press. It is the central component of the entire system, or die casting mechanism. Except for its huge size, it is built similarly and performs equally well as ordinary high-pressure die casting equipment. Vacuum tank. A 4,000-liter tank is used by the Giga Press to create a vacuum inside the mold. It is produced by Fondirex, a Swiss business that developed vacuum technology for high-pressure die casting first. Quenching tank. The quenching tank quickly reduces the casting's temperature to an acceptable level. It enables the achievement of some particular qualities in metal casting. Trimming tool. For quickly trimming away excess metal linked to the casting, mechanical trimming presses and laser trimming are available. A metal scrap recycler. The scrap metals are used in a recycling scheme. Offcuts from the shredding of the scrap aluminum are used in the following casting cycles. Inspection tools. Tools like CMMs and X-ray machines are used to inspect the finished casting. Any production errors by the machine are also listed in the inspection. Technical requirements. There are various GigaPress types with various capacities and sizes. We'll talk about the technical details of the Hydra GigaPress model OL6200CS. In it, 80 kilograms of 180-pound shots of molten aluminum are pumped into the cold chamber casting mold at a speed of 10 meters per second. The output rate is 40 to 45 complete castings per hour, or about 1,000 castings per day, due to the cycle time of 80 to 90 seconds. Let's observe the machine's primary mechanism of operation. Material development. The aluminum alloys and cutoffs from the previous casting cycle must first be melted in an oven at 850 degrees C. The liquid metal is then transferred to another enclosed oven after being cleaned of any impurities using hot pipes. That oven maintains a temperature range of 750 to 850 degrees C. The development of oxides in the molten aluminum is stopped by filling the space inside the storage oven with nitrogen gas. It also helps in keeping the temperature consistent. To further remove pollutants, operators also employ argon gas, a rotary degasser, and a silicon carbide filter. Die preparation. Ensure that the die surfaces are lubricated before starting each cycle. To make it simpler to separate the casting, a robot sprays a thin layer of around 35 milliliters of soybean oil. The vacuum system then generates a vacuum pressure of approximately 50 millibars inside the mold cavity. Casting. From the holding oven, the molten aluminum is sent to the shot chamber of the GigaPress. There, a high-speed plunger is used to drive the molten metal into the hollow. Additionally, 8 milliliters of oil are used to lubricate the plunger before each shot. The casting is injected and then left inside until it solidifies. At 400 degrees C, the casting is then released from the dies. After that, a quenching tank is used to quickly lower the raw casting's temperature from 400 down to 50 degrees C. It aids in eliminating some flaws and enhancing some material qualities. To get it ready for the next cycle, robots carefully clean the open die and cool it to 185 degrees C. Within 1 to 2 minutes of the current casting cycle ending, the next one will start. Finishing. Now, a mechanical trim press is used to roughly cut each raw casting into the desired dimensions. Using a scrap metal shredder, the aluminum scrap is recycled and put back into the furnace. Next, an X-ray is used to check the primary casting to see whether it has any internal flaws. A laser trim and a CNC machine are used to further refine the verified casting before drilling holes for fittings. Finally, use a coordinate measuring machine to verify the precision of the finished casting. Tesla recently unveiled an astounding new video of one of those enormous cast parts emerging from the GigaPress. In the video, you can see the single part, which is essentially 1/4 of the complete car body, still burning after emerging from the press. Now Tesla is going all in on the giant casting technology. Hydra previewed a new 9,000-pound GigaPress earlier this year, which will be the biggest in the entire globe. It was speculated that the new device would be for Tesla in light of Tesla's partnership with Hydra. Since then, Tesla CEO Elon Musk has revealed that the device will be used at the Gigafactory in Texas to produce the Cybertruck body. Several other automakers are said to have contacted Hydra and other producers of casting machines to do the same, since Tesla has been pushing on that path. But because Tesla has been working on this technology for a while and has also created new alloys to perform better with larger cast pieces, Tesla has a major advantage over any other company. Tesla submitted a patent in 2018 called Multi-Directional Unibody Casting Process for a Vehicle Frame and Associated Methods, which describes a new casting machine Tesla intends to use for casting bodies in one piece. A whole or nearly complete car frame can be made using fewer casting machines or real castings if they're used as described. We're yet to hear about the progress on this. This ends the video for today. What do you think about this massive machine? Tell us in the comments. Like, share, and subscribe to the channel for more videos. See you next time.